Okay, so picture this. You turn on the news and there's a storm warning, but it's not for rain or snow or anything you've ever heard of. The forecast is for a downpour of pure glittering diamonds. I mean, sounds amazing, right? The ultimate dream scenario. But let's really think about that. What if, right this very second, the clouds just opened up and showered the entire planet with millions of carats of perfect diamonds? It sounds like a fairy tale, you know? The one event that could solve all our problems in an instant. But would it? And that, right there, is the real question. Because when you take this beautiful fantasy and you drop it into the real world with the unyielding laws of physics and chemistry, that dream twists into a planetary nightmare, and it happens shockingly fast. I mean, at first glance, it's a utopia. The streets are literally paved with jewels. The very idea of scarcity just vanishes. It's like every single person on Earth just won the lottery, all at once. The world is transformed, bathed in unimaginable wealth. But here's where that beautiful picture shatters, and it shatters hard. Our perfect dream is about to run headfirst into its biggest enemy, basic physics. And we've got to start with what's actually falling from the sky. So let's just compare. A raindrop, it's just water. It's soft, it hits you, and it splashes. A diamond, though, is a totally different beast. It's a rigid carbon crystal, one of the hardest things in existence. And here's the kicker. It's over 3.5 times denser than water. So when a diamond hits something, it doesn't splash, it pierces, it shatters. And because it's so dense and aerodynamic, it falls fast. Like really, really fast. We're talking a terminal velocity of up to 40 meters per second. That's almost 90 miles an hour. These aren't gentle raindrops anymore. They're high-velocity projectiles. So you can forget about running outside with a basket to collect your fortune. At those speeds, these gifts from the sky would punch through car roofs, shatter windows, and, well, they'd be absolutely lethal to anyone caught out in the open. This shower of riches is actually a deadly barrage. Okay, but what if we raise the stakes? Let's say this isn't just a weird weather phenomenon. What if the Earth is passing through the tail of a diamond-rich comet, or some kind of celestial debris field? Now, we're not talking about something just falling out of the clouds. We're talking about an orbital bombardment. See, when something enters our atmosphere from orbit, it doesn't just fall. It slams into the air at hypersonic speed. We're talking a minimum of 11 kilometers per second. Not meters, kilometers. The amount of energy we're dealing with now is just on a completely different level. It's almost impossible to wrap your head around. At those insane speeds, the air in front of the diamond can't get out of the way fast enough. It gets compressed so violently that it creates a shockwave of superheated plasma. That's called a bow shock, and it generates a staggering amount of heat. And that heat is the key to the final and most devastating twist in our little story. This is it. This is where the story takes its darkest turn. We've talked about the physics of the impact and the speed, but now we have to talk about the chemistry of the diamonds themselves. And this simple phrase really gets to the heart of the fatal flaw in our diamond paradise. Because for all its beauty, for all its hardness, a diamond is just a very, very fancy arrangement of carbon atoms. It's pure, flammable carbon. So remember that bow shock, that bubble of superheated plasma we just talked about? Well, the heat it creates easily pushes the diamond way past 850 degrees Celsius. And in an oxygen-rich atmosphere like ours, that's the temperature where a diamond stops being a precious gem and starts to, well, burn. So let's just walk through that chain reaction. 1. The diamonds slam into the atmosphere at hypersonic speeds. 2. The air compression heats them way beyond their ignition point. 3. They catch fire. The sky is now filled with millions upon millions of tiny falling torches, which then vaporize into carbon dioxide, dumping all of their energy as raw heat directly into our atmosphere. So the final verdict isn't a world paved with riches. The scientific reality is a world that's been sterilized by fire from the sky. The sheer amount of thermal energy released would literally bake the surface of the planet, igniting global firestorms and scorching the very air we breathe. It's just a perfect storm of disastrous properties, isn't it? The diamond's hardness makes it a bullet. Its orbital velocity creates unimaginable heat, and its carbon chemistry turns that heat into a planetary-scale inferno. Each factor just makes the others worse,
leading to, well, total annihilation.
So what started out as this beautiful, idyllic fantasy ends up as a pretty brutal lesson in astrophysics and chemistry. It really makes you wonder, doesn't it? Our greatest dreams of fortune are often just a few scientific principles away from being our absolute worst nightmares. How thin is that line between a miracle and a cataclysm?